Yeah, another question of great standard, yes. Let's look at this. A transformer with 5,500 turns in its primary winding is used between a 240 AC supply and 120 volts kettle. Something is missing somewhere here. These volts, alright, volts, 240 volt AC supply, yes. Okay? And 120 volt kettle. That means the kettle has 120 volts. Calculate the number of turns in the secondary winding. Calculate the number of turns in the secondary winding. And that calls to mind, we are talking about transformer here, right? We don't know whether it is a step-down transformer or a step-up transformer, all right? Our concern is to find the number of turns in the primary winding, in the secondary winding. So let's go. Let's go. What do you do? First of all, sketch the diagram of a transformer for clarity purpose, okay? Draw it and end more marks. Yes, draw it. The diagram of a transformer in this form, right? Okay, good. This is NP, number of turns in the primary coil, all right? And then this side is going to be something like this, all right? Something like this. This is NX, number of turns in the what? Secondary coil. Number of turns in the primary coil, number of turns in the secondary coil. Hold on. Remember, there is also energy here, which is giving us EP, all right? The electromotive force through the primary coil. And there's also here something like that, EX, the electromotive force or the voltage across the secondary winding, so to say. So we have to look for connection. We have to. Very, very important, we have to. So what's the connection here? Let's bring out our data first of all. A transformer with 5,500 turns, that is NP. Number of turns in its primary winding, NP. NP is equals to 5,500 turns. That's number one. Number two is used between a 240 volts AC supply. That's main supply. The main supply. That is what? EP. Okay, it's giving us 240 volts. Good. And then we move on from there. Supply and the 120 volt kettle. What does this mean? Somewhere here. This is supplying something here. So we have EX. EX is equals to 120 volts. Good. What happens next? We don't have NX. We are looking for NX, which is number of turns, is unknown. Number of turns in the secondary coil. Number of turns in the secondary coil is not known, and that is what we are looking for. That's the value we are trying to evaluate. All right? So let's go. If this has been properly analyzed, therefore we must look for a connection. There must be a connection here. And that connection is very simple. We go with EX transformer formula, that is over EP is equals to NX all over NP. Good. If we have current, we should have as well, it becomes inverse. IP all over IX. But we don't have current here. Okay? So our concern is just here, where our interest lies in. Just here. We don't need current. So let's see. NP, or not all that, EX is giving us 120, 120. Good. And EP is giving us 240, 240. Good. All equal to NX. NX is the one we're looking for. We don't have the value yet. Alright, good. All over. NP is 5500. 5500. Good. We have to do small transposition here. Transpose the letter, the data NX. Transpose it and make it the subject. And it becomes NX is equal to, what happens? 120, we'll go with this. 120 times 5500 all over. This is all over. My chalk. Good. Okay, all over what? 240, yes. 240. Where's my chalk? 240. So, you know what? You are going to finish the remaining one. The remaining step, you will finish it. As a student, convince yourself you have actually understood what this man is saying, okay? That you understand very well. What you need to do, press 120 times 550 all over 240 in your calculator and see what you're going to get. Put the answer in the comment section here, okay? Put the answer in the comment section. Comment that this is correct or this is not correct. Check if your answer at this point corresponds with any of the options given. Yeah. Before I leave you, I must thank you for finding time to watch up to this moment. I sign out at this moment. See you in my next class.